Hello, good day to my examiners. My name is Tan Sin Hao, metric number 184135. This is my final year academic project proposal, and my title is Comparative Study on Bacteriocellulose as Drug Dosage Form in Pharmaceutical Applications. My supervisor is Dr. Suryani Kamarudin, and our batch coordinator is Associate Professor Dr. Tina Idati binti Muhammad Ghazi. So the topics that I'll cover today is first introduction, followed by problem statement, objectives, hypothesis, scope of study, literature review, and lastly methodology. So first, with my introduction, in the pharmaceutical industry, the technology is expanding rapidly because it has increasing number of drug delivery options such as tablet form, capsule form, and excipients, which is also known as the liquid form. So BC fulfills the criteria for consideration of as a drug delivery material, and the usage of cellulose, which is uh, high in demand in the pharmaceutical industry, comprises of plant cellulose and bacterial cellulose. However, bacterial cellulose possesses better qualities than plant cellulose. Therefore, a comparison will be made between BC and an example of PC, which is hydroxypropyl metacellulose, which is also known as HPMC. And later on, I will explain why I decided to compare HPMC with PC instead. And for my problem statement, so PC contains impurities such as pectin and lignin. Therefore, to extract the impurities, more cost would be needed, more energy, and more perhaps maybe unit or method or equipment will be needed to actually extract those impurities. And the impurities will have to be extracted because it will affect the performance later on once it's manufactured into drug capsule form. And aside from that, HPMC capsules are more easily damaged as compared to BC capsules due to higher mechanical integrity of BC. So my objectives are to synthesize bacterial cellulose in the laboratory in HS medium. Secondly, to characterize BC and HPMC for capsule dosage form. Basically, we will be uh, determining the properties of BC and HPMC as a suitability for capsule dosage form. And lastly, to study the effectiveness of drug release between BC and HPMC. um, I have two hypotheses here. One would be BC will have a higher glass transition temperature as compared to HPMC. BC will have higher mechanical strength as compared to HPMC. And for my scope of study, so the first scope of study of objective one will be to conduct BC fermentation in static surface culture with pH 7 and temperature 27 degrees Celsius in the laboratory using HS medium. Why pH 7 and temperature 27 degrees Celsius? Because it is the optimum temperature and also the optimum pH to be used for culture and the growth of Acetobacter selenium, which is the type of bacteria which we'll be using. The second scope of study is using several analytical instruments such as FTIR to analyze the glass transition temperature, SEM to observe the microfibril arrangements, DMA to analyze the viscoelastic properties, and DSC to analyze the chemical properties of BC and HPMC. The scope of study of Objective 3 will be evaluated by solubility study of BC and HPMC in different water temperatures at 4 degrees Celsius, 27 degrees Celsius, and 35 degrees Celsius. The reason why I chose these three temperatures is because 4 degrees Celsius is the coldest temperature which one would usually drink in order to ingest the medicine, and 27 degrees Celsius is the normal room temperature which we would drink the water, and 35 degrees Celsius is the hottest temperature or the highest temperature that we will consume without burning our tongue, mouth, or lips. Moving on to my literature review. So firstly, for bacterial cellulose, Basically, there are certain strain of bacteria that can produce cellulose extracellularly in the form of fibrils. Usually, the bacteria which will be used is Acetobacter selenium. It is because that it produces cellulose that is pure and does not contain hemicellulose. And its advantages are it has high purity, where it is free from lignin and hemicelluloses and waxy aromatic substance. Secondly, it has high crystallinity, high water absorption capacity, and high mechanical strength. Now, these three properties are usually looked into in the pharmaceutical industry. The reason why is because having high crystallinity means that it could be molded easily into any 3D shape that is wanted. Having high water absorption capacity means that it will be easily dissolved once it enters our system. And having high mechanical strength means that it is protected and it has a lesser risk, a lower risk in having damage from delivery time. Bacterial cellulose can also be virtually grown into any shape, such as film or mats, and its disadvantage is that the price for a substrate, which is sugar, is very expensive, and the yield of the process is low. However, there are methods to actually counter this disadvantage, which is um, we could use fruit waste, and fruit waste are abundant since it ranges from peel of fruits such as banana to orange to apple. And aside from that, we could also use a cheaper form of sugar, which is lactose, to culture the growth of the bacteria. Now, this is a structure comparison between PC and PC. So as you can see from the picture on top, wood cellulose, and compared to the picture at the bottom, which is PC, we can see the microfibril arrangements in PC is actually more intricate and complex as compared to PC. And it also covers the whole range of the BC, whereas in PC it only covers a certain part of it. So meaning that in BC it is more densely packed and more orderly arranged. As you can see from here, the drawing on the right is from BC, and while the drawing on the left is PC. So the one on the left, which is PC, it doesn't have an orderly arrangement, and it also has micelles, fringed micelles, so it doesn't have a really firm and rigid shape as compared to PC, and this could affect its mechanical strength and also its polymerization property. Now for HPMC, HPMC is a synthetic modification of a natural polymer, which is cellulose. It is odorless and tasteless, and is white to slightly off-white. Its applications include viscalizing agent, coating polymer, and also capsule shells. Now here are their advantages and disadvantages. So basically, it can interact with APIs, which are poorly soluble, incorporate a gelling agent to achieve enteric properties, provide sufficient taste making, acid resistance to prevent gastric reflux, and also it is a good sustained release tablet material. Its disadvantage is that it is costly, has lower mechanical stability, has lower water absorption capacity, and has low amount of polymerization. Now moving on to our methodology. So the materials that I will need are glucose, citric acid, bacterial peptone, yeast, sodium phosphate, deionized water, and sodium hydroxide in liquid media. And all these, which I mentioned above, can all be obtained from the biochemical lab in the Faculty of Engineering from University Putra Malaysia. And then hydroxypropyl metacellulose, or HPMC, was procured from Sigma Aldrich. And moving on to our preparation of Acetobacter selenium. So firstly, we have to prepare the inoculum. So A selenium was purchased from Mardi, and then we inoculate with 10% concentration in cultured medium, HS medium. And the medium contains glucose, peptone, yeast extract, sodium phosphate, and citric acid. And then after that, the cells were suspended and transferred to HS broth in a glass bottle and incubated at 28 degrees Celsius for 3 days. And there's after that, once it is been once we have the inoculum, then it is added to HS broth, and then it was incubated further for 3 days at 28 degrees Celsius. And after that, we could get a suspended cellulose which had to be washed and purified. And then the cellulose was put into 0.2 molar sodium hydroxide, and then it was boiled for 20 minutes at 90 degrees Celsius. And after that, it can be kept in the chiller for future use. Now for the analysis of the properties of BC and HPMC, so we'll be using firstly FTIR, and it is to understand the chemical composition of both BC and PC, and the wavelength was set at 600 per centimeter to 4500 per centimeter. Then we'll be using SAM to obtain the images of cellulose, and mostly is to determine the morphological structures of BC and PC. Whereas for DMA, so this is the values which we will obtain after the analysis, and we'll be calculating using this formula. So basically, a higher tangent delta means that it has a higher mechanical strength. For DSC, it will be used for measurement of heat flow into and or out of PC based on thermal stability property. And we can also obtain its glass transition temperature and heat capacity. And then the operating range of equipment was set from negative 80 degrees Celsius to 400 degrees Celsius. That's all from me and my final year project proposal. Thank you very much for your time.